Okay, I think I'm going to kick off, guys, and I don't like to keep folks waiting, but we will have a recording of it as well for anybody who does join late. But I think, yeah, what we want to do today is talk through data and data quality, and I know it's probably everyone's single biggest headache, and right now my headache. Okay, there we go. And I think the next two slides are just really important context, because I'm going to sound like I'm contradicting myself throughout the morning, saying that an estimate is okay, but in the next sentence saying that we don't want to estimate. But I think, the important thing is an honest estimate is really, it's a lot better than having nothing there, just leaving that data out. And a lot of people will disagree with me on this in the industry. I actually encourage estimations, or trying to extrapolate data, because what I found is the single biggest thing that stops people actually doing this is a concern around the data. Oh, we don't have the data, so we don't actually get started. And the reality is, like, as your carbon footprint and your understanding of that grows, so does your confidence in the data. So your data sort of almost matures with you. So I think my message from these two slides is, like, I'm going to talk a lot today about what things we can do to get better data and how to improve it, and understanding what's important, what isn't important. And we'll go through a couple of examples of the things that we found people typically find challenging, especially things like third-party logistics and Scope 3 emissions. But my message is, as long as we've got some sort of rational explanation to how we came about this number, it's actually perfectly adequate. I had a chat with a friend of mine who's a ESG auditor in the EU. So they've got like really high standards. And he was saying, the big companies, when they're calculating their Scope 3 emissions, they use like software that just looks at their gross spend on certain suppliers. You can imagine somebody like ShopRite trying to figure out their carbon footprint and all their suppliers who are shipping things in from all over the world. It's an absolute nightmare. And his take on it was, if they can, all he does when they do an audit on this stuff is they look at the methodology. Provided you can just provide a rational explanation, it doesn't actually matter if the auditor agrees with your number or not. It's all down to the methodology. So as long as you've got some rational thought process behind how you got to this number, it is perfectly acceptable. But that being said, we do want to get better with our data. And what we do find is people's carbon footprints actually tend to go down, because when we estimate, the natural inclination is to actually overestimate. If you look at things like firewood, we'll take a batch, we'll apply it across the year, but then we forget that, some of the days are shorter, so you're only burning firewood for half the time. You might have half the occupancy. So I do find that extrapolated data tends to overstate things rather than understate things. But I think my big message is here, confidence in your data will grow as you do this more and more and more, and you'll start instinctively being able to see where the errors are. But I really we shouldn't think about missing data as being a barrier to entry. It's not something that you're going to get penalized on, or there's no detrimental effects. I think the biggest risk is actually not having things just because we can't answer it. So, and this is a really good example that we see here when we look at travel, Scope 1 and diesel. We can get this in a bunch of different ways. And if we apply these emissions factors, we'll get a bunch of different answers. If we look at the actual fuel used, the actual diesel, and we apply an emissions factor against that versus the spend, we'd get a different figure, because our spend, we find we're working on the price of diesel at a particular time, and the price might have fluctuated. So it'll give you a bit of an uncertain answer. Sometimes we look at travel logs and what kilometers we traveled in the car, but then we also have a little bit of uncertainty because we're never quite sure how the person was driving. They could be a really, nice slow driver, easy on the accelerator, could be a more aggressive driver. So your emissions factor for kilometers can be very variable. And then sometimes we would just get an estimate from an ops manager or a driver to say, oh, we've done so many kilometers. The reality is all of these are giving us different numbers, but none of them are actually incorrect. They would all actually be correct, as long as we can explain how we came about it. And every number gives us an opportunity to actually get a little bit better with these sort of things. And we tend to include that in our report. You know, if we're looking at, let's say last year we had to get your diesel from a spend, you know, there'd be the okay, well, then next year we can start actually getting better at measuring this. Let's look at the actual exact liters that we used. So it is a case of continuous improvement, and all of these are actually considered high quality evidence, but they would all give us different answers. I think the other thing that's really important, and I find, you know, it tends to sit on an operations manager, or it sits on a sustainability manager, but getting good data is something that's really important, that we get our whole team involved, because everybody's got a little bit of insight that can make things better. I find the finance guys are normally the first place I go, because most of your emission sources will be documented with an expense. So they tend to have really good answers for a lot of things. Oh yeah, we spend so much on diesel, but oh, hang on, if we look at our diesel log, it doesn't match up to that. It gives us a really good insight. Your operations managers have remarkable insight into, you know, where fuel is going, which vehicles that were put into. You know, we've got a total for diesel, but we don't know how much went to generators, and we don't know how much went to game drive vehicles, and we don't know how much went to staff travel. You know, your ops guys are normally the guys that can answer those sort of questions. When it looks at procurement, you know, they're procuring things. They're getting your third-party transport to deliver food and veg and food and beverage every week. They've got a lot of detail that will be very useful for you. Same goes for the maintenance guys. The guides often have really interesting insight into vehicle diesel. And then, you know, management. Sometimes we look at we need to increase the scope of operations, or we've added a new camp, or we've added extra beds. So my point is here that it needs to be a team effort. And what we do find, when data is coming from one source, you can often cross-check it across different sources and get a far better picture. So if we've got a total diesel from the financial records, the ops manager will be able to give you a little bit of insight into that. Or the guides could give you a bit of insight into, but we had a case a couple of weeks ago where we saw a particular lodge's diesel was just sitting way outside of norm. No one could understand it. But the guide actually said, hey, hang on, we've been doing transfers from a particular airport for the past 2 months, and that airport's 200 kilometers away. Suddenly it makes sense. The guide could give us really good insight into a significant anomaly that no one else could explain. But the guide knew, oh, no, I've been driving to that airport, you know, 3 times a week for the past 2 months, which is something we didn't do before. So in the whole team, there's always, everybody's got a little role to play and can add that layer of accuracy and a bit of insight. Because a lot of it, what we mentioned in the last session, that, you know, the number is actually fairly irrelevant. It's the insight we can get from that number and what we can compare it to and what we can learn from that number. And across your team, everybody's got a little role to play in making that a little bit more accurate and reducing those uncertainties. So I think when we're looking at it to know if it's trustworthy, we're looking at 4 questions. You know, can you verify it? Do you have some sort of evidence? That could be an invoice, it could be a fuel log, it could be an odometer on a car, it could be a solar dashboard where your kilowatt hours of generators being captured. Can you trace it? So do you know how you actually came, where that source of information comes from? Can you explain it? And I think this is especially useful when we're making assumptions.
Hi, it's Kelly.
So,
Els, could you please bring me my
can you explain it? And I think this is really important when we've extrapolated. I'm going to go through some real examples here where we've, you know, things like firewood doesn't get measured every day, but we can do a sample and we can explain our logic behind that sort of sample process. So this is really important for things that we find are difficult, not your diesel, electricity. There tends to be good records, but other data sources, sometimes you do need to kind of put a bit of thought process and extrapolate and guesswork. And as long as you can just outline that logic, this is how I came to that number, and this was my thought process. it's perfectly adequate. And then could you defend it? So if somebody says to you, how did you come up with this number? And I think this is the most important part. If somebody asks you, how did you come up with this? You just need to be able to defend it with whether it's an invoice or a calculation that you used or a specific set of assumptions, then it's perfectly defendable. But that sits alongside the fact that not all things are equal. And this is something also really encourage you to think about, because what we do find is that the least relevant sources of information become your biggest pain points. So if we look at, and this is off our entire database, we look at where emissions sit. 75% is sitting in diesel, LPG gas, petrol. Firewood is 0.9%, so it's not even 1%. But it is the one emission source that we find gives people one of the biggest headaches. They really battle to actually, oh, we've never measured this. And it is just, let's do a sample. So I think my point is here is we focus what we call materiality, where your biggest impact is and where your biggest margin of error sits, is inevitably a place that you should initially pay more attention. Of course, over time, you want to get better at it. But focus your attention on the big emission sources. So if it is LPG gas and we don't have a good measurement for gas, we've just got an invoice and we've had to apply an average cost per kilogram last year, then next year we put in a system to get a little bit better with LPG gas. Similar with diesel. Last year we only had the cars kilometers. We've got a particular figure, but this is an important emission source. Let's do a few things next year to understand how many liters we used, which vehicles that diesel was put into. Was it generators? Was it game viewers? So over time things do get better. So I think the message there is measure what matters the most. And this is a really interesting little slide, because when we look at our own data scoring, the most important one of the lot, the one that's counterintuitive, is actually has our weakest average score. And I think this is because in almost all cases, diesel is purchased, but it can't be split as to what was for a game viewer, what was staff transport, what was for a generator. So we find you start getting these big uncertainties in something that's actually really important. And people are spending a lot more time getting good data for the less important things. And this is just something we've noticed over the years. And I think these figures here come from our own database. So it's quite, it's almost quite clear that people are spending a lot more time and thought into data that actually isn't as important as the stuff they should be putting attention to. And I think this is my big message. If there's anything to take away from this entire session today, it's that things do get better over time. So year one, when you get started, you might have to estimate things. You might not have documents to back it up. You might not be able to replicate that way that you measured it in year one again. Year two, you start building evidence. Year three, you start putting in different systems in place so that you can better understand. So it could be things like, the generator diesel. Year two, you've kind of looked at it as a percentage of diesel, or it might be a shortfall on your solar, and we've calculated diesel of that. Year three, we've actually got a log on the generator measuring actual kilowatt hours. So as you go on, these little bits of data, these uncertainties just get less and less and less, and you get better and better at getting your data. And then at a point by year four, everything's relatively automated potentially, and everything. The procurement guys understand that once a month they send you details of everything that was purchased. The finance guys send you a record of diesel spend so you can match it up with your actual logs. So yeah, for me, this is probably the single most important thing. It doesn't need to be perfect from year one. It's a process of what we call it data maturity. So as your data matures, so does your confidence in that data. So let's look at a few examples of what we typically often see where errors can creep in with the data. So I think, you know, for most of you that we've worked with, we've been able to come down to fairly accurate assumptions. We've been able to measure most things. But what we sometimes find is there's these little things that slip in that make data uncertain. I think a combined bill is a classic one where we've got the numbers get bundled in together. So we could have a bill for diesel, and that diesel has gone into the generator, and then we've gone and measured the kilowatt hours for that generator. So it's been done separately. So keeping the billing as separate as possible really does make a difference. So if we're filling up generators, it's a separate bill to when we're filling up, for instance, game drive vehicles, and being able just to trace that source back. So that's typically one we see. Also, we see it quite a lot with electricity, where we've got multiple meters, and we've got a total electricity bill, and then we get the little multiple meters, and they don't really add up. And this often comes in where things get reported as one, but they're actually multiple different things. And that really, what it really does is it doesn't change your total, but it hides the detail and the story, and it stops you from getting the intelligence that you want to out of that. Another one is missing context. Again, if you look at something like this, where you've got somebody submitted electricity, we've submitted diesel, we've submitted gas, but we don't have any context for where that was used and over what time period, it tends to hide really important information. So the context, I think, is a really, really important thing to have. You know, whatever data source we've got a context for where it was used, who used it, you know, what's actually included in that. And this is particularly important for things like, for fossil fuels, diesel, LPG gas, even electricity. When you're trying to understand how much is when you're trying to look for these opportunities to save, but we don't know where that was actually consumed, it hides the detail. LPG gas is another fantastic one that we see a lot of, where we get changes, massive changes in LPG gas, but we're not sure if it was used in the kitchen. We're not sure if it was used for heating of hot water, or it might have actually been used in the staff village. And actually just understanding that context allows us to actually understand the footprint of that LPG gas in so much more of a meaningful way. So now we know, hang on, this is an issue with the kitchen. It's not an issue with LPG gas. That's an issue with how we're using gas in the kitchen. So context is really, really important. Another one is to pick up on anomalies, just these unusual spikes. So you can see everything looks fairly stable, and then, well, you've got a month that's higher or a month that's lower than the rest. And often there's a legitimate explanation for it. It could be, you just had a really busy occupancy period, or we had to run the generator for extra hours because we were filling up a water hole. So there's normally a really good explanation for these, but often they do indicate errors. And then it's a case of, going back to the ops manager, why did this happen? Oh, no, that didn't happen. Oh, we realized somebody's added an extra 0 by accident in the Excel spreadsheet. So a lot of the time, these little unusual spikes, just noticing them and interrogating them improves your data quality significantly. Because what we do find with these, when we get these little anomalies, is 9 times out of 10, it's just it's a data input error. Somebody's added a 0, or we've gone and measured kilometers instead of liters, and it becomes very explainable. But those little unusual spikes are things we see a lot, and the moment you start digging into them, you get really good answers out of it. The other one that's really important is double accounting, and this is something we do try very hard to avoid. And the classic place we see it is with solar installations and generators, and we're measuring the generator through the same system as the solar, and that's being accounted for. And then we go and we measure the diesel that went into the generator as well, and you actually end up measuring the same emission source twice. So that's a really important one, just get your head around where we get that information from, and how do we know that it's not actually being counted somewhere else. And this is, we see it quite a lot with third-party transport as well, where we are accounting for third-party transport on all our supply runs, and procurement has said this is what we purchased and this is what the weight of it was. But actually that supply run got done in a company-owned car. So what's happening there is we're counting a scope 3 emission, a logistics transport emission, where the diesel in that car has actually been accounted for already in your scope 1 emissions. So these are the little typical things that we see cropping up with data, where we get you know, these typical little anomalies. I think the double accounting is a really important one to look out for, and those unusual spikes. Of the two of these, I think these two probably tell you the most. The unusual spikes, they're always there. They're worth interrogating, asking some questions about, and being very careful that, yeah, if we're doing anything in a company-owned car or fuel that's been accounted for already, we don't double count that. Has anybody got any questions on these before I go on to a couple of like real examples of the areas that we find are typically really difficult for people?
Duncan, something I would quite like, I'm sure the others would as well. Could we get these in a format that these are printable out for us?
Yes, absolutely. I'll share this this with you.
Yeah, I think that would be very useful.
I'll definitely do that, Tim. Yeah.
And then the other one is possibly as to whether these sessions, and maybe they are, I missed the last one, if they're recorded or not.
They are, yes. So I've got the last one on YouTube, and I'll share the links with the links to these with everybody. Yeah. Cool. Anybody else got any questions on these little gremlins or other gremlins that they do see popping up in their data? Cool. So I'm going to go through a few like just real examples here of things that we find are always challenging for people. We find scope 1 emissions, diesel, petrol, by some means, whether it's a spend on your general ledger on fuel, or it's invoices or tracking systems from cars. We find scope 1 is normally, you know, normally quite simple for people because we just need kilometers or we just need distances. Whereas things like firewood, waste, supplier deliveries, and staff commuting, these four, which we do include on almost every accommodation establishment carbon footprint, these tend to be the most problematic. And I'm going to go through each one of them just with an example of ways you can do it and get it better and better year over year. So I think if we look at firewood, you know, what you want to do, typically what we have for the first year is, oh, jeepers, we've never measured firewood. It's a scope 1 emission, so it's quite important. How do we do this? First year, the ops manager might say, oh, well, we use a wheelbarrow a day, and we go and estimate how much wood fits into a wheelbarrow, and we spread that out across the year. It's not great. It's not taking into account fluctuations in occupancy or anything, but it's a starting point, and it's the best we've got right now, and that's perfectly fine. Then in year 2, what you actually want to do then is, okay, let's actually weigh what's in this wheelbarrow. So we're not estimating what's in the wheelbarrow. We're actually getting an exact weight of what each wheelbarrow load is. We know how many loads we use a day. We can extrapolate that out. So it's a little bit less guesswork, but it's a bit better. Even better, what you could do is just weigh it once a quarter. So we do a sample weight once a quarter, because then we also kind of picking up changes in occupancy. We're also picking up changes in you know, daylight hours and how warm it is. You probably burn more firewood in the winter than you would in the summer. Evenings are shorter. And this starts capturing seasonality. And then the most accurate way would be every time you get a delivery of firewood, that gets weighed. So we've got the exact data there. Sometimes if you do procure firewood, you're generally paying X amount of rands per kilogram or X amount of rands per ton. You can work it back from there. But we can see here how we can start off with a very simple way of doing it. And then, each year it just gets a little bit more, I don't want to use the word more complex, but it gets a little bit more detailed. What we want to avoid in these sort of scenarios, and I think the next one is, what is this third party? I'll keep that for this, that little antidote for waste, is, is keeping it practical. Asking anybody at a lodge who's trying to deal with, a group of 10 guests and everybody's coming back from a game drive and you've got all of these service things and real problems to deal with. Now you're going to ask people to go and weigh the firewood every day. It can become a really laborious task. And what we don't want is to create these barriers to entry. I just find the moment it starts becoming overly laborious for people, then you end up getting nothing out of it and it becomes a pushback. And what we want is people to actually be on board and supporting the process and getting involved and understanding. And that's why I find doing something like this, where you're just getting a little bit better at it each year without making it an absolute mission for everybody, is really valuable. Another one is third-party delivery. So this is probably hands down the one we end up having conversations about the most. I think the most important thing here is to make sure that when you are measuring third-party deliveries, it's explicitly restricted to deliveries that are not coming in your own vehicle. So if you've got your own truck that's going to town and fetching supplies and coming back, that diesel is already accounted for. So you do not need to count that. This would only be restricted to when you're getting deliveries from people like Bidvest, or you might have a local supplier who brings you fresh vegetables once a week, or once a month somebody delivers gas. It's those sort of things. So an acceptable estimate is just to sit there and think, sure, we've never measured this. Nobody measures it. Very few people measure it off the bat. And a perfectly acceptable starting point is, okay, how often do we get deliveries? Once a month we get a delivery. Yeah, I'm guessing it weighs about half a ton, and we extrapolate that out over the year. It's not a great start, but it is a start, and we've got that data. A second way to do it a little bit better would be to, okay, we're going to weigh just one sample delivery, and we're going to note what sort of truck it was. So now we know, because we generally know the distance. The truck has come from, if you're on the Wild Coast and the truck has come from Port Elizabeth, we can calculate the distance there. We know the distance that was traveled. But weighing everything on that truck is a real pain. So we estimate it, but we know exactly where the truck came from and what sort of truck it was. That's already given us now a slightly better level of confidence. An even better way is to go to your procurement guys and say, can you give us a shopping list of everything that we got delivered last month? And a really handy trick is just to take that shopping list, you upload it into any AI model, whether it's ChatGPT or Claude or whichever one, and just ask it to give an estimated weight of all of these items. So it'll give you a fairly accurate figure of that. So now we've actually got an actual weight of the delivery. We know what kind of truck it was. We know how far that truck came. So now we've got really good detail. And then first prize here is you actually work with a supplier who can give you the exact weight and the exact distance. So you can see from something like this, where we started off with having to really guess it, just by implementing little systems over a period of time, we can get from a fairly educated guess down to real, actual, detailed data that comes directly from our suppliers. And sometimes I know it's not practical for some suppliers, especially if you trying to use local service providers, or you're using getting food and beverage from small farm providers, those sort of things that can be tricky. But yeah, the easiest way is even a photograph. I found AI can be really, really good at estimating, the weight of what is in that. So it's 5 crates of beer and, a whole bags of groceries and whatever. You can get that sort of thing. But what we find is the second one here, where we're just weighing a sample and we're getting an average of how often that got delivered, and we know where it came from. I find that very, very, very acceptable. It's not perfect, it's not exact, but it's really acceptable, and especially in the context of where we work in a remote area, to weigh 400 kilograms of deliveries is just totally, it's difficult and it's impractical. So my point is, sometimes it can be a complicated thing because you've got multiple deliveries coming from multiple suppliers. But yeah, a good way there is just to get your procurement guys to give you a shopping list of what was in that, and then you'd have your weight. And once you've got the weight, you know where the trucks come from, and then it becomes fairly easy to measure from there. Waste is another one. And very similar to the deliveries, it comes down to weight. And, again, asking a chef who's really busy trying to feed a whole bunch of very fussy people to go and now start weighing everything before he throws it in the dustbin, it's probably not going to get the result you want. A good starting point is if you've never weighed waste before, but you want to get an idea, there's industry averages. So we've got a fairly large database, so we know what the average per bed night organic waste is. There's a whole giant tourism industry database that says on an average bed night, the average tourist produces so much waste. So there's a lot of averages that we can use from the industry, which again is perfectly acceptable. It's a referenced source, and that's a good starting point. But managing your waste is also beyond your carbon footprint. It's so it's normally quite an important ESG reporting thing as well. Like we did with the firewood, we can just sample it across a period of time. So we can sample it during an average occupancy week, spread that out across the year, or we could say, this is what we had last night and we had 20 guests. So therefore, when we got 40 guests, we got double of that. So sample and estimate. You could sample and actually measure. So then what we want to do then is understand what goes to recycling, what gets composted, what ends up on landfill, and without actually having to measure everything, you could just, again, do a sample like, okay, today we had X amount of organic waste, 20% of it went to the pig farm, another 20% went to our composting garden, and the rest was mixed in and it ended up on landfill. So there we've kind of we're starting to get a better picture of what's actually happening to our waste. And then in an ideal world, every time waste is going off to a landfill site or going off to recycling, it's actually weighed. And again, if you do work with a waste management company, you can also then start putting pressure on them to give you exact weights of what they were removed. And we're seeing this quite a lot with waste management companies now. They give very good data. But if you're managing it yourself, just a sample across an average week of what you're producing, what goes to recycling, what goes to landfill, is perfectly adequate. We've even found some examples of, waste to landfill that we've applied in KZN, where we know some of these landfills aren't just landfills, they're quite dynamic places where there's a lot of waste recovery happening, and we've applied estimates to that, where we've said, okay, we've got a ton going to landfill, a ton of plastic going to landfill, and we know that there's people there who are collecting all of those plastic bottles, and we work on a 30% gets left and 70% gets reclaimed from those waste pickers, and we've applied those sort of examples. So there's a lot of ways you can actually get around that to just at least try get a decent picture of where your waste is and what's going to landfill, what's not, by just using a sample period. But yeah, first prize is obviously to weigh every load, and yeah, some people are really consistent and good at weighing and managing their waste. For other operations, it could be a very complicated thing. But it's about just getting better and better at those processes, and just, yeah, next year, we're just let's focus on our organic waste, because by weight, organic waste, wet waste tends to be the highest. Let's just measure our organic waste next year and get that good. The year after, we can add plastic and paper if we need to, but it's a continuous improvement process. The other thing that really comes up is once you start getting more data, and once you've done this for a few years, and I know most of you guys and the guys we work with, we've done a baseline and it's only been a year that you've been doing this, it's very hard to spot things that are unusual. But what you will find, and I think is as you get more and more data, your your range starts getting narrower. So you almost instinctively know how much LPG gas you use a month. You instinctively know, sure, this is how much diesel we use, and suddenly there's a spike. You can spot those anomalies and spot things that don't really make sense. It becomes so much easier with time. So I think, that's quite an important little message here. Is, you could look at your first year's data, and it's very difficult for you to look at it and see anything that's maybe incorrect or that's been over or underestimated. But as the years go on, or even as the months go on, it becomes easier and easier and easier to actually spot these little outliers or these little anomalies. And that allows you to also respond a lot quicker. Because when you spot something that happened last month, it's really easy to figure out what happened last month. But if you spot something 12 months later, and now you've got to figure out what happened in April last year, it can be really, really complicated. Cool. So that's my lot on data. So I think the key message is there. It's something that we want to get better on year over year. Doesn't have to be perfect first time. And if we do have to estimate, or we do have to extrapolate, or we do have to apply some assumptions, the important thing is just that we can rationalize it. It's just there's a big difference between saying we used 10 tons of firewood last year versus, okay, we've weighed firewood on an average night and we've extrapolated that out across the year. One is a guess. The other one is still a guess, but it's a guess that's based on some logical thinking. Anybody got any nagging questions on these for me? You're also welcome to pop anything in the chat. I see there is about Dale. Yeah, Dale, I will share that previous session video link with you guys. So it is on. I do have it on YouTube, and I'll share that across.
Fantastic, Duncan. Thank you. I've got to get going, but this is all great stuff. Very, very useful. So thank you very much for putting this together for us.
Cool. Thanks, Tom.
All right. We'll chat soon.
Cool. Thank you.
All right. Ciao. Bye.
But if anybody's got any questions, you're welcome just to drop me an email anytime or reach out. Sometimes just to understand a thought process around data you have got, and we've got some months, we're missing some months. How do we make this a year? I'm always happy to talk through that. And that's something I did also fail to mention during the session. Sometimes we do have missing months. We've got 11 months of electricity, but for some reason we can't find May, but we've got everything else. It's perfectly acceptable to use the average of the other months and apply it to May and just say, this is what we've done, and this is what we're doing next year to make sure we've got a complete set of records. Cool. Thanks so much, everyone.
Thank you, Duncan. Appreciate your time.
Thank you, guys.
Duncan.
Oh, JK. Cheers.
Cheers.
Bye.
Cheers. Thanks, Duncan.
Ciao.